to logistic regression, how the logistic regression works. Before understanding the logistic regression, let us understand the linear regression, because logistic regression was created using the linear regression algorithm. So we are having a input variable that is experience and output variable called as salary. Okay, these are the two variables. And based on these two variables, I'm having a scatter plot. Okay, this is the scatter plot between input variable versus output variable. I'm having only one input variable and one output variable. Now, what I'm going to do for this, since the salary, whatever the output variable salary is there, since the salary is a continuous variable, I'm going to apply the regression concept, where for regression, I'm going to identify either simple linear regression or multiple linear regression. If multiple input variables are there, means multiple. If only one input variable is there, means simple linear. But I'm going to apply the linear regression, and using the linear regression, I'm going to identify the best fit line. I'm going to identify the best fit line, which gives the sum of the squares of errors as minimum. I have to identify this line. Out of infinite number of lines, multiple infinite number of lines are there. Out of infinite number of lines, which line is the one best one, means which line is having the sum of the squares of errors as the minimum, that is the best fit line. These things we have discussed in the linear regression. Now, coming to classification. Now, if you make a scatter plot between the input variable versus output variable, your scatter plot will look like this. Okay, if you take any input variable, any classification related project, because in the output variable we are having either if it is a binary classification algorithm, let us assume some kind of binary classification. Okay, just give me a minute. Okay, let us assume we are having the output variable some kind of binary classification. So in the binary classification, either we'll have yes or no, something, either true or false, or accept or reject. Okay, something we are going to have. Now, for example, I'm having in the output variable something like this: COVID positive and COVID negative. Whatever the example we have worked earlier, let us take the same example: positive, negative, positive, negative, 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 positive. Something you are having the data like this, and some input variable called as age. Age of the person is 22, 28, 29, 34, 22, 24, 25, something you are having like this. Now, this is the input variable and this is the output variable. This is the input and this is the output. Now, if you draw the scatter plot, so to draw the scatter plot, since here the words of negative and positive words are there, these things first we have to do the encoding. First we have to do the encoding. Since it is a binary classification, if you do one hot encoding or label encoding, there will be no difference. So simply I'm going to do the encoding called as 1 0 1 0 0 0 1 0 something. Now if I make a scatter plot, now what happens? Some data points, for example 22 comma 1, this is the 22 comma 1 data point. Next 28 comma 0, this is 28 comma 0. 29 comma 1, this is 29 comma 1. 34 comma 0, 34 comma 0. If you make a scatter plot between them, all the data points will lie either on 0 or 1. Okay, because each data point, if you take first data point, 22 comma 1 is the first data point, 28 comma 0 is the second data point, 29 comma 1 is the third one. So like this, you are having in the y variable either 1 or 0 only. So either your scatter points will be on the 1 or either on the 0. Every time your scatter plot will look like this only for all the classification problems. Whenever you take the classification algorithm, automatically you'll observe the scatter plot in this way. That is the reason why we should not apply the scatter plot between one continuous variable versus one discrete variable. Scatter plot should be applied between two continuous variables. If you remember in the Seaborn, when I'm discussing the scatter plot, I have told that this is scatter plot is a bivariate analysis of a continuous variable. Two continuous variables are there, then only the scatter plot will give the correct answers. If one continuous variable and one discrete variable, if you apply, then it is not a proper analysis. You can't do anything on this particular scatter plot. Now, for example, for all the classification related projects, we are having the output variable either zeros or ones like this. Now in this case, how we have to fit a line? How to identify a best line? Similar kind of linear regression, how to identify? If you make a line like this, whatever we have done earlier for the linear regression, the best fit line, in the same pattern, if you apply and if you apply the same thing, and if you draw a linear line like this, now in this only 1 or 2 points will satisfy and the remaining all the points will have the error, which we can't apply this logic. Now what we have to do in this case? So if you apply this logic means only this point and this point will satisfy, remaining all the data points will not satisfy. Now, in this case, what we are going to do is that linear line, we are going to convert as another line called as sigmoid line. So how we are going to fit a line means the best fit line is going to be as a sigmoid line. This is the best fit line. Instead of going with a linear line as a best fit, we are trying to fit with a sigmoid line. Now, what is meant by this sigmoid line? Sigmoid line is nothing but here you are having y is equal to beta naught plus beta 1 x. The same thing, just you are going to modify using a sigmoid function. This sigmoid function where it is equal to p is equal to 1 divided by 1 plus e to the power of y. This is called as sigmoid function. Most important. Okay, most. Keep how many, whatever you want. Okay, in the entire data science, this is the important equation. In the entire data science only, it is the important equation. You can believe in that way. Wherever the binary class is there, sigmoid plays the major role. Whether it is in logistic regression, whether it is in the gradient boost, XGBoost, some kind of advanced algorithms of ML, and even in the neural networks, in artificial intelligence also, the same sigmoid is going to play a very important role. Now, what is meant by sigmoid function? Sigmoid means it is going to calculate the probability. So what is the probability means? P is equal to 1 divided by 1 plus e to the power of minus y. P is equal to 1 plus e to the power of minus y. Now, what is meant by y? Y is nothing but whatever your linear equation is there, that is your y. Your linear equation is beta naught plus beta 1 x. This is your linear line. So the probability is equal to 1 divided by 1 plus e to the power of beta naught plus beta 1 x. Means first you are going to calculate the normal y hat. From the y hat, you are going to calculate the probability. Means, for example, a data set is there like this. Let us take a data set. You are having x1, x2, x3 and y variable. Where in the y variable, if the y variable is continuous, we are going to calculate y is equal to, if the y variable is continuous, we are going to apply the y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. If y is continuous. Now the same y, same example is same. That is, you are having x1, x2, x3 and y. Same example. But this time the y is discrete. In this case, what we are going to do is first we are going to calculate same to same as y by assuming the same to same. Beta 1x plus beta 2x2 plus beta 3x3. The same equation we are going to calculate. After calculating this y will be converted to probability. First y will be common. After calculating the y will be converted to probability by substituting in 1 plus e to the power of minus y. Okay, whatever the value you have got here, you are going to stop here itself. In this regression equation, what happens means you are going to use your model and you are going to calculate this value. After calculating this value, directly you are going to compare with the original value itself. Whatever the predicted value and the original value, and you are going to calculate y minus y hat in the regression algorithms. But here, whatever the y value you have calculated, after this you have to convert to probability. So where the probability is equal to 1 divided by 1 plus e to the power of minus y, which is also called as e power y divided by 1 plus e power y. Both are same. If you substitute this 1 divided by 1 plus 1, this, which is nothing but e power y plus 1 divided by e power y, which is equal to e power y divided by. So if you expand this same equation, and this one, both are same. Right? Both the equations are same. Now, if you observe here, in this equation, if you observe, e to the power of y divided by 1 plus e to the power of y. Whatever the y value you substitute, whether the y value is a positive or negative, whatever the y value you substitute, the numerator, whatever the numerator you are having, the numerator is always, in this case, the numerator is always less than the denominator. Because e to the power of y, whatever the value is there, below 1 plus is there. Means obviously no, denominator is somewhat more only, right? 1 point is more. 1 point is more means automatically denominator is more. So now whatever the values are there, every value will be less than 1 only. You can't cross more than 1. Using this sigmoid function, what happens in the sigmoid function means all the values you are converting between 0 to 1. The least to least is possible is 0. Okay, if e to the power of y is completely equal to 0 means, in that case, what happens? In that case, what happens? If e to the power of y is equal to 0 means, what is the probability value? 0 divided by 0, 1 plus 0, which is equal to 0. In that case only the probability is going to be 0. Never it is going to cross more than 1. And never it can't be equal to 1 also. Because e to the power of y, when it can be probability equal to 1? When e to the power of y is equal to e to the power of y plus 1, then only it is going to be 1. It is never possible. This equation is never possible. So since it is never possible, so 1 also never possible. Okay, and it is going to be less than 1 only. So always the probability value is going to be less than 1 in this case. Now, second, here we are having whether the 0 will be included or not, whether we can get the 0 or not. When we'll get the 0? When the probability will get the 0? When the probability is going to be 0 means e to the power of y is equal to 0. When e to the power of y will be 0? When you are having log e to the power of y base e or log 0 to base e, that is y is equal to log 0 to base e, which is infinite. When y is infinite value only, the probability becomes 0. But in the equation, y is equal to beta naught plus beta 1 x1 plus beta 2 x2, whatever the equation you are having, never the y is going to be infinite. Because if you substitute some x values or some y values and beta values, automatically you get a finite value only. So to be more precise, now the probability is not equal to either 0 or not equal to either 1. It will be between 0 to 1. Here I have to use 0 to 1. I have to use less than or equal to 1. That is I'm explaining. If 1 is also possibility is there means I have to use less than or equal to 1. If 0 possibility also is there means I have to use 0 is less than or equal to. Since 0 is not possible and 1 is also not possible, so I'm going to remove this equation in terms of equal to symbol. 1 is not possible, 0 is not possible. Only between 0 to 1. So now whatever the probability you are having, the probability is going to be between 0 to 1. Now, if I expand this equation, whatever the equation I'm having, that is p is equal to 1 divided by 1 plus e to the power of minus y. If I expand this equation, that is e to the power of minus y is equal to e to the power of minus y is 1 plus e to the power of y is equal to 1 divided by p. I'm just sending this one to this side and this one to this side. Right? Now, 1 e to the power of minus y is equal to 1 divided by p minus 1, which is equal to 1 minus p divided by p. E to the power of minus y is equal to this one. Now, where e to the power of y is equal to p divided by 1 minus p. Now, if I apply both the sides log to base e, if I apply log to base e on the both sides, P divided by 1 minus P, which is nothing but Y is equal to log E P divided by 1 minus P, which is log E is also represented as ln. What is the difference between ln versus log? Ln means the meaning is log to the base E. Log means log to the base 10. By default, log means log to the base 10. Whenever you want to apply with respect to log to the base E, you have to use the word called as ln. In our calculator also, scientific calculator also will have ln and log separately. Ln means log to the base E. Now P divided by 1 minus P. This is our Y. Now what is meant by Y? What is Y? Y is nothing but your linear regression, that is beta naught plus beta 1 x plus beta 2 x2 plus whatever the equation you are having, which is equal to ln of P divided by 1 minus P. So this is called as logit function. This is only logit function, means logistic regression. Out of logistic regression, the first word logistic is there, right? That meaning is this one. So the beta naught values are calculated based on the probability values. Is that clear, guys? So the equation, how you have got the equation means this equation, that is beta naught plus beta 1x is equal to ln of P divided by 1 minus P. This equation you have got from this one. Just expansion of the equation only. Expansion of the sigmoid function only, nothing else. Is that clear? If you want, you can write the equation. If you want, you can write. Okay. This is called as sigmoid function. This is the most important point. Sigmoid function. Now, what is meant by sigmoid function? Sigmoid function means whatever the value you are going to give, whatever the Y value converts to the corresponding probability is called as sigmoid. Whatever the value you have given and converting to the corresponding probability is called as sigmoid. It is called as sigmoid function. Now, question is why? Why we have to convert to probability? First question is why? Why we have to convert? Second question is why we have to use this equation? This is the second question. Now, first question, coming to why we have to convert to probability means because our data, whatever the output we are having, the output is I'm having a binary class. The output consists of binary class where I'm having zeros or ones, right? And in my scatter plot also, I'm having the equations with respect to either zeros or ones. Now the scientist, whoever the scientist who is working on this first time on the classification algorithm, if the data points are like this, if the data points are something like this, if the data points are like this means we are substituting an equation like this. Now for this one, how we have to create an equation? Generally, for any linear regression, normal linear regression, if you are having only 3 data points or 4 data points, assume you are having only 4. Generally, which is the best equation means which will pass through the given data points is the best one, because it will give the error is equal to 0. Directly error is equal to 0 only. Similarly, they also tried with respect to fit all the data points in a single equation, single line. How we can fit a single line? How we can fit with a single line all the data points to be combined? Is there any possibility? They identified, and this equation is the sigmoid equation. The best line which passes through all the data points. They identified which line will be passing like this. What they have done is they have taken only, similarly how we have taken here 4 data points. For example, in linear regression, 1, 2, 3, 4. 4 data points are there. For these 4 data points, which is the best equation means this is the best one. Similarly, what they have done is they have taken the 4 data points. For classification also only 4 data points. This is the first one, this is the second one, third one, fourth one. Now they want to identify the 4 data points which gives the best combination. They want to combine. they got the idea first like this. This is also combining. This is also combines. Like this, multiple will combine. Now, as the data points increases, for 2 or 3 data points, the problem is very simple. As the data points increases, more data points increases, then the complexity increases. For 2 data points or 3 data points, easily we can combine the linear regression also. If you take x is equal to 1, 2, 3, 4, 5, and y is equal to 6, 7, 8, 9, 10, for this simple data set, we can get 100% accuracy. But for real data sets, we can't get the 100% accuracy, right? For this data set, 100% is possible. For real data set, 100% is not possible. So they tried with respect to for real-time data set, and more amount of data points are there, which equation is giving the minimum error they identified. They identified which equation out of, again, infinite number of equations, which equation gives the minimum error. Means they came with a solution called as sigmoid equation will give the minimum error. How it is giving the minimum error means in terms of, first they are going to calculate the linear regression. Since already linear regression was designed on the minimum sum of the squares of errors, here itself we are getting the minimum values. Directly here itself we are getting. Now these values just they are converting to the corresponding probability. Okay. Now finally, what is the output of logistic regression? What is the output of logistic regression? Sigmoid function. From the sigmoid, what we are going to get? Output. Probability is the output. Now, whatever the, for each record from the logistic, in the logistic regression, it is working on a concept called as sigmoid. Okay, logistic entirely works on the concept called as sigmoid, where p is equal to 1 divided by 1 plus e to the power of minus 5. Okay. Now, what is the output of sigmoid function? What is the output, miss? Probability is the output. Finally, miss, in the logistic regression, what is the finally you are going to get? Probability as the output. Now, probability means it can be 0.1, 0.2, 0.3, 0.4, 0.92, 0.91, but values will be between 0 to 1 only. In 0 to 1 also, infinite number of values are there. Between 0 to 1, infinite number of values are there. Now, the output is probability. Okay. Now, whether it is predicting the directly the answer of classification zeros or ones, or it is predicting the continuous variable. Which one it is predicting? It is predicting with respect to probability, where the probability is a continuous variable. It is predicting the output as continuous. It is not predicting the output which is discrete. My requirement is either zeros or ones. This is my requirement. This is my requirement, and you are predicting the probability. For example, first record is there. First record. For the first record, the original y is 0. And you are predicting the probability. The probability is 0.22, something you are predicting. And second record, the original answer is 1. And you are predicting the probability as 0.64. And third one, probability 0. You are predicting probability as 0.76. Next one is 1. You are predicting the probability of 0.94. Next record, original answer is 1. You are predicting the probability of 0.56, something. My requirement is original answers are zeros or ones are there, but you are predicting the answers are probabilities. Now, whatever the probabilities you are predicting, so these probabilities are which are continuous. The output is continuous. But I don't require the continuous as my output. I require the discrete as the output. Now, what I have to do is convert the continuous value to a discrete. How to convert a continuous to discrete? Discretization. We already discussed the discretization, right? Same to same. Same logic it is going to apply. So now it is going to apply the logic of discretization, that is converting the continuous variable to discrete variable. Now, after converting continuous variable to discrete variable, now whatever the continuous variable we are having, that is probability, the probability will be converted to discrete variable. Now, how it is going to convert to discrete variable? Means it is going to select the threshold. It is going to work on the concept called as threshold. Threshold means some value. So it is going to take from 0 to 0.5 as class 0, from 0.5 to 1 as class 1. It is going to take like this. Now, wherever the probability is less than 0.0, less than 0.5, wherever the probability is less than 0.5, it is going to convert as answer as 1. Wherever the probability is greater than 0.5, it is going to convert answer as, with respect to wherever the probability is greater than 0.5, it is going to convert as class 1. Wherever the probability is less than 0.5, it is going to convert as class 0. Now in this case, what is the predicted y hat? 0.22 is there. Now what is the answer? 0. 0.64, 1. 0.76, 1. 0.94, 1. This is 1. Now you are having the predicted answers also either zeros or 1. Original answers are also zeros and 1. And it is comparing. How many of them are correctly predicted? Correctly predicted, correctly predicted, correctly, and this is wrongly predicted. Now, out of these 5 records, 4 of them are correctly predicted. 1 is wrongly predicted. The accuracy is 4 by 5, which is nothing but 80% is the accuracy. It is going to work in this way. Okay. Here it is going to select based on the threshold. Here the threshold value, it is selecting as 0.5. Less than 0.5 as one class, more than 0.5 as another class. This 0.5 is default value. It is not fixed value. Now the question is how we are going to select this threshold value. This is the next question. How we are going to select? Every time 0.5 only, or are we going to change? For example, I'm changing the threshold value to 0.7. Now, if the threshold changes to 0.7, what is the meaning of that? Means any value greater than 0.7 is considered as class 1. Any value less than 0.7 is considered as class 0. Now, automatically, this is y hat. Whatever the y hat we have predicted, this is the y hat. Whatever we have predicted y hat for threshold. What is the threshold? We have considered 0.5 threshold, and this is the answers. Now, if the threshold I'm changing to 0.7, now tell me what is the answers? Threshold with 0.7. First one is 0, less than 0.7 is 0. This one, 0. This one, 1, 1, and this is 0. Now threshold changes, answers changes. Now if I change the threshold to y hat, threshold with 0.8. Whatever the value is less than 0.8 should be converted as class 0. Wherever the value is greater than 0.8 should be converted as class 1. Probability is not going to change. Probability is not going to change. Oh, based on the threshold, answers are going to change. So 0, 0, 0, 1, and 0. As the threshold changes, if you observe, as the threshold changes, your answers are also getting changed. As the answers changes, automatically TPR changes. Now, if you draw a curve, if you take a curve and for different threshold settings, that is threshold setting of 0.1. For threshold setting of 0.1, you'll get one TPR and one FPR value. For threshold setting of threshold setting of 0.1, you'll get a TPR and FPR. Threshold of 0.2, you'll get TPR, FPR. Threshold of 0.3, TPR, FPR. Threshold of 0.4, TPR, FPR. Threshold of 0.5, TPR, FPR. And if you draw a line like this for various threshold settings, then it is called as ROC curve. That is the meaning of ROC curve. Okay, sir. ROC curve. Okay. Tell me what is the best threshold number? First, tell us that answer. Here, there is no best threshold value. Here, there is no best threshold value. If anyone asks you the question that how to identify the best threshold value in logistic regression, means we are not going to depend on single threshold value. We are going to take different threshold values, and based on the different threshold values, we are going to draw a plot between TPR versus FPR. And we are going to calculate the area under the curve, whatever the area under the curve. And which model gives me the AUC as the maximum, that is the best model, right? Having. And yeah, online students, is my voice is loud and clear? In between, due to internet disconnectivity, it was dropped. Now it is clear. Done. Okay. So everyone can able to see the screen also, right? Screen is also clear, right? Okay, fine. So now I'm having x1, x2, and y variable. Okay, a normal linear, normal data set. This is the version data set, and I have given to the logistic regression. Now, when I have fitted on X train, Y train, assume this is the data fitted on X train, Y train, it is going to apply the linear regression first. So after applying the linear regression, for each one, it is going to calculate the Y hat. For each record, it will calculate the Y hat by applying the linear regression. After applying the linear regression Y hat, now every value will be converted to probability. Now Y is there now. Using the Y, it will convert to the probability, that is 1 divided by 1 plus a to the power of minus y hat. It will calculate the probability. Now, after calculating the probability, I have got the answers like this: 0.64, 0.24, 0.9, 0.9, 0.8, 0.6, 0.54, 0.32, 0.4, 0.69, 74, 80, something you have got like this. This is the probabilities you have got. Up to here, it is over. Okay. Now, after this, with this, it is clear. Up to here, it is clear. First, it is applying the linear regression. From that linear regression, it is calculating the y hat for every value. After calculating the y hat, from that, it is calculating the probability. Once it is calculated the probability, now it is going to take the threshold. Starting first threshold of 0.1. Threshold of 0.1. Let us start with 0.1. Threshold of 0.1. Any value less than 0.1 is considered as 0. Any value greater than 0.1 is considered as 1. Now tell me what is the answer. Now what is the y hat you are going to get? This is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. You are having the original y with you, actual y, and predicted y. Both of them are there. Can you calculate the TPR? Can you calculate the TPR? How to calculate the TPR? First, you are going to make the confusion matrix. After making the confusion matrix, from the confusion matrix, you are going to identify the TP value, FP value, FN value, and Tn value. Using that 4 values, now you are going to make the TPR. What is the TPR formula? TP divided by TP plus Fn. You are going to calculate the TPR. And similarly, you are going to calculate the FPR. You will get one value, some value. Write that one. Keep this side. Now change the threshold to 0.2. Any value less than 0.2 is considered as class 1, class 0. Any value greater than 0.2 is considered as class 1. Now in this case, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Now you are going to calculate once again the TPR and FPR. In this case, both of them are equal. Here you got the both of them as equal. Now let go with the 0.3, threshold of 0.3. Now you are going to calculate the wherever the value less than 0.3 as class 0, greater than 0.3 as class 1. 1, 0, 1, 1, 1, 1, 1, 1, 1, and 1. Now automatically TPR and FPR changes. One record changes also automatically either FP or TP or Fn. Any one value will change. Automatically, if any one of the value changes means automatically TPR changes. TPR changes and FPR also changes accordingly. You calculate the TPR and FPR. Save that value. Next, go with the threshold of 0.4. Go with the threshold of 0.4. Now, in this case, 1, 0, 1, 1, 1, 1. This is 0, 1, 1, 1. Now, according to that TPR and FPR, original value is this one only. This is the actual, and this time this is the predicted values. Automatically, you'll get the TPR and FPR for this one also. Next, for 0.5. Again, for 0.5, calculate the same to same y hat. That is 1, 0, 1, 1, 1. This is also 1, 0, 1, 1, and 1. Next, go with 0.6. Next, 0.7. Next, 0.8. Next, 0.9. And finally, with respect to 1. Like this, you calculate for each of them. For different threshold settings, you calculated the TPR, FPR like this. Now, total how many TPR and FPR values you are having with you? Total how many are there? This is first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one, 10th one. Total 10 are there. 10 TPRs are there, 10 FPRs are there. Right? So can I make a box like this? Using my TPRs and FPRs, can I create with respect to, once this is done, once it is done, can I create like this? For threshold, for each threshold, separately TPR and FPR. For threshold of 0, I'll have 1. For 0.1, TPR and FPR. For 0.2, TPR, FPR. For 0.3 threshold, like this, I'm having total 10 values. 0.6, 0.7, 0.8, 0.9, and 1. I'm going to have total. If I take 0 means 11 values will be there. If I don't consider 0 means 10 values will be there. Now total, I'm having the values like this. Now, can I make a scatter plot? Instead of scatter plot, line plot. I'm making a line plot. Line plot between what? Between TPR versus FPR. Here I'm taking the TPR and FPR. Using the first record. Here one TPR and one FPR is there means, can I make one point like this? Can I create one point? Using these two values. Using TPR and FPR, can I keep one point? Okay. For example, TPR is there 0.4 and FPR is 0.1. Can I create with respect to 0.4 comma 1? This is a 0.1 and this is the height of 0.4. Can I create one data point like this? For this, can I create one more data point? For this, one more data point. 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 And if I attach all the data points, that is line plot. Scatter plot, what are the scatter plot points are there. Attaching all the scatter points is called as line plot. In the sequential order, attaching them is called as line plot. I'm applying all of them line plot. Then it is called as ROC curve. Now it is clear how to draw the ROC curve. ROC curve means TPR versus FPR. A curve between TPR versus FPR at various threshold settings. It is not with a single threshold. It is for various different thresholds. For different thresholds, you are going to get different values, and that different values you are going to present in a graph. Okay, if one threshold only fixed threshold is there, 0.5 is fixed means one TPR and one FPR only will be there. Only 1 point will be there. From where you get a line plot? Only one data point only will be there, right? If threshold of 0.5 is locked every time, fixed locked every time, then only one data point will be there. Now it is clear, guys. Let us see this. In the last class, whatever I have done, that is evaluation metrics for classification. Evaluation metrics for the classification. So this is called as ROC curve. Now ROC curve means the full form is receiver operating characteristic curve. That is the full form. But what is the meaning of this one means ROC curve is a metric that assesses the model ability to distinguish between binary classes. When there is a binary class, in that case, apply the ROC curve. This logic is not applied for the multi-class. It is only applied for the binary class. It will work very well suited. Though, sir, so binary instead of binary class, multi-class can apply means there is one way, but you will not get a better result. You will get a good result only for binary classification. Logistic regression works very good for the binary classification, not for the multi-classification. Still, if you want to try also, you can give, but you'll get a wrong answers or very low answers. Right? Now, ROC curve is created by plotting the TPR versus FPR at various threshold settings. TPR versus FPR at various threshold settings. You are making a curve like this. Now, here, if you observe, 3 curves are there. What is these 3 curves, sir? 3 different models. If you take only one model, means one curve only will be there. If you consider 3 different models, 3 different algorithms, and if you want to compare between them and if which is the best one. Now, out of these 3, for example, let us assume this is the this black line I have got using the ML algorithm 1. This green line I have got using ML algorithm 2. This red line I have got using ML algorithm 3. 3 lines I have got. For each algorithm, ROC curve, it is different ROC curves I am getting. Now, out of these 3, which one is best? Which one is best? Or to be more simplified, without data cleaning, I have not applied any kind of data cleaning or anything. Just means without treating the outliers, directly first I have created one model and I have got the ROC curve, this one. After cleaning the outliers or after cleaning something or transforming the data, now this time I have got this one, green color. Now red color is good or green color is good? This is question number 1. Now I have tried one more way. In that way, I have got this one, black color line. Now total 3 lines are there with me. Red color line, black color line, and green color line. Every line are there. Now out of these 3 lines, which line is best? Means which model is best? Which model is best means which gives the highest AUC value, that is the best model. What is meant by AUC? AUC means area under the curve. Whatever the area. So for example, here I am having the blue line and green line. Out of these 2, which is having more area below to that? Green will have more or blue will have more? Green will have. Comparatively, green will have more area below to this. Area under means below. Area under the curve means whatever the area below to that line. So area below to the line, the higher the AUC, the better the model. Okay, if the AUC value is equal to exactly 1 means perfect model for various thresholds. If you change the threshold also, still it will work perfectly. If you change the threshold also, it will work. Not only for a particular threshold, for various thresholds, still the model should work. To be more simplified for you, sir, I'm getting confused, sir. Can you explain with the one real-time example? Let us take one real-time example. Let us see this banking and finance industry. In the banking and finance industry, how this banking and finance industry works means based on the interest what they are collecting from the public. How they are getting the interest means they are lending the loans. First, they are lending the loans, and from the loans, they are collecting the interest amount, and using the interest amount, they are running the banks. Every bank and finance sector works on the same. So they have to give the loans and they have to collect. They can't stop the loans. If they stop the loans means the banks will collapse. Because from the savings account, in the savings account, the public will get from the bank. And for savings account infrastructure, and for the bank's offices, ATMs, and with respect to internet banking services, customer care services, for all these things, money is required. No one can do for free of cost now. You are saving your money. Okay, in the bank, you are saving your money. Okay, fine. But how the bank is working? For example, bank works, for example, let us take like this. 10,000 rupees is the minimum balance amount you have to maintain in the bank. And you are maintaining. It is not even debiting even 1 rupee also. 1 rupee also it is not debiting. Okay, perfectly whatever the amount you are keeping in your bank, it is keeping as it is, including the paisas also, it is keeping as it is. Not even 1 rupee also it is debiting. Now, how the banks will work? For saving your, just saving your money, if the bank has to work means, from where they can create all the infrastructure. So the means they have to give the loans. Now they have to give the loans. Means to give the loans, every bank will have some money with them. Okay. For example, let us take the bank is having 10 lakhs with them. Assume bank will have more amount only. Example 10 lakhs. 10 lakhs they are having. Now this 10 lakhs they have to give to a person, and from that person they have to take the interest money. Right? They can't keep with them. They have to give to the others, and they have to take the interest. Now, for giving the interest, for giving this money for the interest, they have to identify a right person. There will be in the market, multiple people will be there, out of which one of the person like Vijay Mallya also will be there. He will also be interested to take the money, but he is not interested to repay the money. For taking the money, everyone will come. When repaying the money, no one will come. Right? So taking the money is very simple, but repaying the money is difficult, right? Now, here, this money, whatever the money I'm having, this money I have to give to a right person. If I give to a wrong person, what happens? Forget about the interest rate. First, the main amount only will be lost. Right? So now here, now banking industry, how it is going to work? The entire banking industry, how it is going to work means based on the lending loans. And now what are the different types of loans means? One is secure loan. Second one is unsecured loan. Secure line like gold loan, housing loan, car loan, bike loan, all these are secure loans. If you don't pay, automatically they'll take this one. Okay, they are called as secure loans. For secure loans, the interest rate will be low. The interest rate, whatever the interest rate is there, it will be low. Now coming to the second option called as unsecured loan. Unsecured loan means they're not having any kind of security. Means if you don't repay, they can only beg you. There is no other option for them. Please give us, please give us. They have to ask. Okay, there is no other option for them because they're not having any security now. If, for example, gold loan, if you take and if you don't pay, automatically they'll sell the gold and they'll repay balance amount to you. They are having the right to sell that one. If you take a housing loan and if you don't repay, they'll sell the house only. Without your permission, they'll sell. They are having the right. And in the terms and conditions, you'll sign that one also. If I don't pay for you, you sell my house without my permission. You'll give the one. And car loan, same to same. If you don't pay the car loan, they'll seize the car and they'll keep with them. If possible, they'll sell also in the auction. and the balance amount they will pay for you. Okay. Now coming to the unsecured loan, it is completely based on the trust. By trusting you, they have to give. The word called as trust. Only one and only word, trust. If they trust you, they'll give you. If they don't trust you, they'll not give you. Simply they'll reject the loan. This is unsecured loans. In the unsecured loans, risk factor is somewhat high. Compared to secured loans, risk factor is high. So that is the rate, that is the reason interest rates also will be high. When you are working on a project, you have to do this much of in-depth analysis. Understand the business problem. Whether to accept a loan or reject a loan means simply downloading the data from Kaggle and import pandas as PD and read CSV, not that one. We have to understand what is meant by loan, and if the person don't pay loans, what happens, how it is going to impact the banks, and what the banks exactly look for, and how the banks work. Everything we have to learn. That is the business problem. That is the research we have to do. If required, we have to go to the bank and we have to discuss with an executive and if what is the process, step-by-step process. So that we'll get also more clarity to do that particular project work very clearly. Right? Now, these unsecured loans where the interest rate will be very high. Now, what they are going to do is they are going to take the application form, and the application form, they are going to take all your details. And once they have taken all your details, okay, this is your data. Now, already, let us take this example with HDFC Bank. HDFC Bank, already 10 years old bank, assume. It is more than that, 10 years old. In this 10 years, they have already given the loans and they have recollected the money. Some of them has paid, some of them has defaulted. Okay. In that entire 10 years, assume they have given the loan to the, assume they have given loan to 1 lakh customers. In the last 10 years, they have given loan to the 10 lakh customers, 1 lakh customers. Out of these 1 lakh customers, almost 99,000 people has repaid their loan. Okay. And 1,000 people, they have not repaid the loan. They have not repaid. Whoever has not repaid the loan, they are called as defaulters. They are called as defaulters. As per the bank terminology, they are called as defaulters who has not repaid the loan. Right? Sir, 1 month late or 2 months later I have paid means, then you are not considered as a defaulter. Defaulter means never they will pay. Simply they will ignore the bank only. They will take the money and never they will pay 1 rupee also. Then they are called as defaulter. After 1 month late with late fine also you are paying means you are not considered as a defaulter. Okay, semi-defaulter. That is secondary. Now, defaulter and we are having with respect to the person who is going to default the loan. Now here, the previous 1 lakh records, whatever the 1 lakh records we are having, this is the entire data is used for our training purpose. In this, we are having the output variable, either the person has repaid or not repaid. 1 means repaid, 0 means not repaid, assume something like this. Now we are having the data where input is there, at the same time output also is available. Last 10 years data. Now once using these 10 years data, we are going to create the ML algorithm which identifies more accurately on the last 10 years data properly. Once the algorithm was designed, now on unknown data, for example, tomorrow you are going to apply for the HDFC Bank, a personal loan, and you have filled the details. Now using your details, it is going to predict whether you will default the loan or not default the loan. It will predict like that. And based on the prediction, whatever the machine has predicted, based on that, the credit manager is going to take the decision. Now, why I have told this entire story is, here in this entire story, most important point is the machine is going to predict the answer I have told you, right? This answer, whatever the answer it is going to predict is probability. What is the probability that this person is going to repay the loan is going to predict the probability. The output it is going to give is the probability. So now it is going to give the output as probability. For example, I have got a probability of 0.9, means 90% this person is going to repay the loan. 10% there is a chance of he is not going to repay the loan. The whatever the output we have got, the credit manager will be there. Credit manager. He's not bank manager. He's different person. Credit manager. This credit manager, finally, he is going to take the decision whether to give the loan or not to give the loan. Before to COVID, that is March 2020, before March 2020, that is in the month of February, January 2020, at that time, the threshold value is 0.65. 0.65 means who are having the more than 65% that they will repay the loan, they have given the loans. During the COVID situation, they have brought this one to 0.85. During the COVID, from March to September 2020, where we are having the lockdowns, multiple lockdowns and everything, continuation of lockdowns. At that time, many of the people has not received their full salaries. Many of the people has lost their job. And many of them has struggled at that time with respect to the financially. At the time, they have applied the loans for the banks. When you apply for the loans in the month of March or in the month of April, it is going to ask the pay slips of January, February, and March. Based on these three pay slips, they have given the loan on the April 2020. Actually, they have to give like this generally. But particularly in the April 2020, what happened is suddenly they have raised this one to 0.85. Because in the April month, many of the people has not having to eat only money properly. Now, how they can pay the EMI? They have felt in that way. Simply, they have cancelled the many loans at that time. This threshold, whatever the threshold is there, this threshold was changed to 0.85. This one was taken by decision by the bank manager. Bank manager or the entire HDFC bank head, whoever the personal loans head is there, right? He has taken the decision. And based on that decision, in the back end, we have to change the code. So here the threshold is not every time fixed. This entire story what I have told is the threshold will not be fixed. To say that one, I have told this entire story. Okay. The threshold will be dependent on the requirement on the project. By default, it is 0.5. By default value is 0.5. It is a default value only. It is a default argument and default argument value is 0.5. But every time it is not going to fix. Now, if, in the given question, they have not given us the threshold value, assume. In the business problem, they have not given the threshold value. Then which threshold value I have to select means don't fix on the single threshold value. The model should be giving the best answers for various threshold. As I change the threshold also, still my model should give the best answers only. As the threshold I change also, still my model has to give best answers only. Means you have to identify which gives the AUC as the maximum. Within the logistic regression, which one is the best one means which gives the AUC maximum, that is the best. Is that clear now? Completely. That is with respect to logistic regression and ROC and AUC. So there is no fixed threshold value. The interview question would be like this. What would be the threshold value in logistic regression? Means, so by default, the threshold is 0.5, but it is not a fixed value every time. We are not going to fix on a single value. As the threshold changes, the TPR and FPR changes, we are identifying which is the highest AUC. We are not going to depend on threshold. We are going to depend on AUC. That is the answer. To be more simplified. And if the interview someone asks you which is the best threshold value miss, threshold value is not the important parameter. AUC is the important parameter. Based on the AUC, we are going to decide, not based on the threshold value. In the business problem, directly they have asked for the particular threshold miss, we are going to set the whatever the threshold value. Otherwise, with respect to AUC. Is that clear? So in the logistic regression, first we are going to identify the equation, that is y hat, From the y hat, we are going to calculate the probability, and based on the probability, we are going to identify the discretization, that is threshold. So once for every value, you are going to calculate the corresponding probability. For each and every value, what is the corresponding probability you are going to calculate? For in the equation, for every x value, for every equation, you are going to calculate the probability. The output is probability. And based on the threshold, it is converting as class 0 or class 1. So now you are having the probabilities with you, and you are going to take a threshold of 0.5 as a default parameter. And whichever the values are greater than 0.5 will be converted as class 1. Whichever the values less than 0.5 will be considered as class 0. Now, why it is considered as logistic regression? Why the name is regression is there? Interview question. Output is, yes, output is continuous, which is probability. That is the reason why it is logistic regression. That is the question. Right? Everyone will assume logistic regression will give the answer as zeros and ones. No. Logistic regression will give the probability. Logistic regression basically gives the output as probability, not the zeros and ones. Whatever the probability you are having, based on the threshold, you are converting that one. Clear, guys? Logistic regression. That is in-depth of logistic regression. How the logistic regression works and what is the meaning of threshold. And as the threshold changes, what happens? Yes, one ROC. For one model, one ROC is possible, not for one data set. Whatever the model is there, model.fit and xtrain, ytrain you have given, right? For that, one ROC. Now, if you change the training data, that is, you have cleaned the data. Earlier, you have not treated the outliers. Now, this time you have treated the outliers. Now, the data is different, right? As the data changes, automatically ROC changes. Right? Clear? Any questions on logistic regression? Theoretical part. Let us go on to the coding part. Coding part, nothing will be there. Import logistic regression, fit on xtrain, ytrain, predict on xtest, predict on xtrain, calculate the ROC. Coding part, nothing will be there. Nothing will be there. By default, it will take the 0.5. Unless you want to change the threshold value, by default, it will take automatically. 0.5 automatically it will take, and it will only do. And directly you can calculate the AUC only. Right? Coding will be nothing. In the interview, they'll not ask how to write the logistic regression code. They'll not ask this question. In the interview, then none of them is going to ask how to write the logistic regression code. In the interview, they'll ask you many questions from logistic regression. First question is, what is sigmoid? What is sigmoid function? Why logistic regression is called as regression classification algorithm? Though there is a regression word, why it is called as classification algorithm? Or why logistic regression is having the word called as regression? Right? And next one, what is meant by threshold value? Next one, what is meant by is threshold value is fixed every time. And next one, which threshold value should be considered in the logistic regression? These are the interview questions in the logistic regression. Clear? One by one. Done. So let's move on to the coding part of the logistic regression. Okay. Now, since we are having only 15 minutes of time, in 15 minutes, we can't complete the coding part. So just let's do one more algorithm. The one more algorithm is KNN. This is one more algorithm. These two of them will do the coding in the tomorrow's class. Let's complete the theoretical part of KNN. This is the dead easiest algorithm of entire data science. Entire ML, this is the dead easiest. Than this, nothing is easy. And this is the lazy algorithm. This KNN is also called as lazy algorithm. Why? You have to tell me the answer at the end. After understanding KNN, tell me why it is called as lazy. Okay. Now KNN. KNN means KNN means nearest neighbors. K nearest neighbors. Algorithm name is called as K nearest neighbors. Okay. K nearest neighbors. Now, for understanding KNN in a simple way, in a dead easy way, I'll tell you like this. Okay. In a class, not in a class, in a college, two groups are there. In a particular college, two groups are there, group 1 and group 2. In this group, certain students are there. Multiple students are there. In this group, multiple students are there. This is one group. This is one group. Okay. Now you are entering for the first time into the college. Now you join whether into this group or whether into this group. It is not MPC or BPC. This is not that group, or civil engineering or mechanical engineering. This is not that type of group. Next level of group. Okay. Right. This is a normal general category groups. Okay. Where the friends are there and they're going to maintain the group. Okay. Not bad group, good group only. But this is a different group. They're friends. These people are friends. Separate. Right. Now, which group you are going to join? Miss, how you are going to select? Generally, in this class, if there are two groups are there, in this class, everyone are not friends, right? Everyone knows everyone? No, right? So certain people of one group and certain people of one group. Like this, we are having, right? Multiple groups are there. Now, one new person is there. This new person, he has to join in any of one of the group. He has to select either this one or this one, 100%. There is no other option. You have to select. Don't say that I don't select anything. You have to select. Then in that case, how you are going to select? You are going to identify how many friends you are familiar with in this group and how many friends you are familiar with in this group. If, for example, at least 3 friends are there, something. Here only one person you know, but here 3 persons you know. Now automatically what you'll do? You'll choose this group, right? Simple. That is KNN. That is only KNN miss. KNN miss one new data point is there. For that new data point, 2 groups will be there. Out of these 2 groups, which group is best one miss? Which group is having more similarity for this particular data point? And miss nothing but similarity miss here friend. Okay. So more number of friends are in which group, it is going to identify and it is going to join into that group. It will be classified. Join means nothing but classified. Friend means nothing but distance. Friend. Okay. Friend means nothing but friend is equal to, your friend is equal to close distance. If the distance is low means he is your friend. If the distance is high means he is not your friend. Who are sitting side by to you, he is your friend. Who are sitting in the first bench and last bench, why they'll be friends? If they are friends means they'll sit side by side now, while they'll sit in the last bench. Why one student will sit in the first bench and why one student will sit in the last bench? Why 2 people are sitting side by side means because they're friends. Simple. Right? Distance. If you calculate the distance between them, if the distance is low means they are friends. If the distance is very high means they are not friends. Simple logic, right? Now here, whatever the friends we are having, that is nothing but distance. So just I'm going to calculate the distance. So this entire algorithm works on the concept called as distance concept, right? This entire algorithm works on the concept called as distance. So here, again, I'm showing you there are 2 categories are there. Okay. This is X1 and this is X2. X1 and X2 and Y. A data set consists of X1, X2 and Y. And I'm going to make a scatter plot between x1 and x2 by writing hue is equal to y. In the CBurn, there is a hue is equal to option, right? You can divide the data into two parts. So I'm going to divide like this, two parts. Now I'm having x1 variable, x2 variable. The output is red and green. The output is red and green. Two categories are there, either red or green. Now there is one person, a new data point. There is a new data point. Now this new data point belongs to red category or green category. Means it belongs to the red category. How? Means it identifies which is very close to this. Red point is very close to this. Red. If green point is very close, means green. Right? Just it is identifying the distance. Right? So how this KNN algorithm works means, first choose the number of neighbors. How many numbers you want? First you have to choose the number of K. Since we don't know that value, that is the reason we are writing here the K. So we are going to try for K is equal to 1 to infinite. Hyperparameter tuning. The K will be the hyperparameter and where we have to try with the different values of K. Now, once the K is fixed, take the K nearest neighbors of the new data point according to the Euclidean distance. Okay, as per the Euclidean distance, calculate the distance between the data points. And among the K neighbors, count the number of data points in the each category. Count the number of data points in each category. Assign the new data point to the category which you counted the most neighbors. This is the algorithm. Write in the notes step by step. Lazy, take the photo. I will explain with an example, step by step, everything. Visual representation, I will show you. First, you have to choose the K is equal to some number. You have to assign some number for K. Take the K nearest neighbors. Among the K nearest neighbors, count the number of data points in each category and assign the new data point to the category where you counted the most neighbors. Done. Let's see an example. Before starting an example, you guys know what is Euclidean distance? How to calculate the distance between two data points? No. Okay, not a problem. Let's see that one also. What is meant by Euclidean distance and how to calculate it. Let us take a scatter plot. In this one of the data point, this data point is x1, y1. What is meant by x1 means this is x1 value and this is the y1 value. This is the point. Okay, there is one more data point here. This is x2 and this is y2. There are two data points are there, either here or here, wherever it is. Two data points are there. Now between these two data points, this is x2, y2. Now between these two data points, you have to calculate the distance. Now, for this, what I'm going to do is, first I'm going to make a horizontal line from here to here, exactly, horizontal line. Now tell me, what is the distance of this one? What is the distance from here to here? From x2 to x, y is changing, y is not changing. Only x is changing. That is x2 minus x1 or x1 minus x2, anything. Okay, either x1 minus x2 or x2 minus x1. Choice is yours. You can consider, not a problem. Right? Now, from here to here, what is the distance from here to here? This time x value is fixed. X value is locked, only y value changes. This is y2 minus y1. Now I'm going to draw a straight line till this line and this one matches. So that this is a straight line, this is also a straight line. Now I want the distance between these two. So now here it is going to make a right angle triangle. For right angle triangle, hypotenuse theorem, where I'm having this one is nothing but this is, if it is A, this is B, and this is C. Now C square is equal to A square plus B square. Hypotenuse theorem, right? That is nothing but x2 minus x1 whole square plus y2 minus y1 whole square. C is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. This is the Euclidean distance formula. From where you got the Euclidean distance means like this. Is that clear? So this is Euclidean distance formula, right? So now, for example, I'm having two data points. That is x1 and x2, 1, 4, 3, 8, 9, 11, 12. I'm having like this. Now, this is the record number 1, record number 2, record number 3. Now, I want to calculate the distance between record 1 and record 2. Now, how to calculate the distance between record 1 and record 2 means square root of 1 minus 8 whole square plus 4 minus 9 whole square. For example, I'm having x3 also. That is 0 and 1. Something like this I'm having. Then 0 minus 1 whole square. If you are having x4 means x4. x5 means x5. Like this, how many are there? Everything. Right? x2 minus x1 or x1 minus x2, anything or same, because whole square only you are going to do now. Yes, a record of this one, a record of record of 1 and record of 2. That is with respect to this one is considered as x1 and this is x2. This is second variable of y and this is the second variable of y. Right? That is 1 minus 8 and 4 minus 9. The distance between these two. Now record 1 versus record 3. What is the distance between these two records? Square root of 1 minus 11 whole square plus 4 minus 12 whole square plus, for example, like this I'm having 0 minus 1 whole square. Now, what is the distance between record 2 and record 3? Square root of 8 minus 11 whole square plus 9 minus 12 whole square plus 1 minus 1 whole square. Now, out of these three, now tell me which distance is low? Which distance is low? Record 2 and record 3 distance is low. Means they are close to each other. Simple. Like this, we are going to calculate the distances. Is that clear, guys? Now, how to calculate the distance? Now here, choose the number of k neighbors. I'm choosing the k neighbors is equal to 5. I'm choosing the k neighbors is equal to 5. For example, you are choosing k neighbor is equal to 1 or 2 or 3, whatever it is. I'm explaining for k is equal to 5. Later, I will explain for k is equal to 6, 7. Like this, I will explain. First, k is equal to 5. Step number 1, choose the number of neighbors. I'm choosing the neighbors is equal to 5. Now, as per the neighbors is equal to 5, what is the second step? As per the Euclidean distance, you have to identify the 5 nearest neighbors. So from this data point, I'm going to calculate distance, 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 distance. Like this, for each and every data point, I'm going to calculate the distance. For each and every data point, I'm calculating the distance. After calculating all the distances, I'm identifying the top 5. Top 5 distances which are close to this data point. And I have got 3 red points and 2 green points. So among the k neighbors, count the number of data points in each category. I'm calculating among 5 neighbors, 3 of them are red, 2 of them are green. These are the 5 which are close. For this data point, these are the 5 close. Out of these 5, 3 of them are red, 2 of them are green. Now, next, what is the step number 4? Among the whichever the highest, assign the new data point to the category where you counted the most neighbors. Means now this one you have to assign as a red because more number of neighbors are red. Is that clear? Is that clear, guys? Simple. Sir, for example, now the question is, okay, step-by-step process, okay. Now, for this data point, for example, let us start with k is equal to 1. Let's start with k is equal to 1. What step-by-step process? What is the process? First, choose the k value 1. As k value 1, identify the one nearest neighbor. Who is the closest nearest neighbor for this one nearest neighbor? Nearest means out of all of them, who is the very close? That person is called as nearest. So it is going to calculate the distance. For each and every data point, it will calculate. Sir, why to calculate, sir? Very clearly, it is very clear now. So in this scatter plot, it is very clear. If the you are having 10 variables means you can't draw the scatter plot now. Manually scatter plot, we are not going to draw the scatter plot for 10 variables, right? So in that case, what happens means in the backend, automatically it is going to calculate for each and every record, it will calculate the distance. Total, how many data points are there? For each and every data point, it will calculate the distance. Once it has calculated, it will identify the closest one is red. This is the closest one. Okay, identified. After identifying, what is the next step? Step number 3. What is the step number 3? You have to count. So I'm counting how many red are there, how many green are there. I have considered only one. That too, one is red only. Now, what is the next step? Step number 4. Assign to the closest data point. What is the closest one? Red. So it will be converted to red. Finally, it will be converted to red. Now k is equal to 2. Now k is equal to 2. 1 is completed. 2. Now again, it will calculate the distances. Identify which are the top 2. And it has identified the top 2 as, assume the top 2. Example like this. This one and the second one is this one. Assume this is the case. If this is the case, top 2 are these are the 2. And it has identified 2 of them are red and automatically it will be converted as a red category. It is going to assign as a red category. Now, for example, it has identified 1 red and 1 green. Now, how it is going to choose? If this is the case, how it is going to choose? Whether it is 1 red and 1 green means, now it will identify the distance with the red and distance with the green. Out of these 2, which is low, it is going to assign to that category. If both of them are same means, second priority goes with the distance. Sir, for example, 4 are there. You have taken k is equal to 4. This 2, 4. Now how it is going to calculate? Again, 2 is there. So total red distances, total green distances, it is going to add separately. If the red distances total is low means, it will convert to red. If the green distances is low means, it will convert to green. Sir, green distances and red distances are also same. Now what happens? It will select anything because there is no difference now. There is no difference now. If there is no difference, how we can differentiate? So automatically it will select by default, it will select the green. Why? Because green letter is first letter na 0, red followed by 1. So by default, it will select the 0 class. If number of categories are same, at the same time, distances are also same means by default, it will go to the class 0. Is that clear? Generally the k value, we are going to select the odd numbers. How we are going to select the odd numbers means in hyperparameter tuning, give the k value is equal to list of range of 1 to 101 with the increment of 2. Automatically all the odd numbers only it will select. It will identify first k is equal to 1, k is equal to 3, k is equal to 5, k is equal to 7, k is equal to 9, k is equal to 11, k is equal to 13. It will identify with only the k values of odd numbers, and from that odd numbers it will identify which is the best. Instead of giving the even numbers and getting that, instead of that, mostly k will be odd numbers. If the k is even, in that case, how it works also I have told you. Is that clear, guys? KNN. That is the simplest algorithm of entire ML. Now, why it is called as lazy? Can anyone? Why it is called as lazy? Anyone? So in order to calculate the closest distance, it has to calculate for every data point the distance. For example, in the training data set, if you have given 10,000 records means 10,000 distances, it has to calculate. For every data point, it has to calculate the distance. So for calculating every data point, the distance, it will take time. So whichever is taking more time, that is called as lazy. That is the reason it is called as lazy. Lazy means in terms of it takes more time for doing that work. And that is the reason in real life, KNN will not select. For large amount of data sets, KNN is best suited for the small data sets, not for the large amount of data sets. Is that clear? So that is the end of the session. Any questions? If you have any questions, you can ask. Otherwise, you can leave. So tomorrow's class, we are going to see the code